Quadratic equations are equations that include an x squared term, and usually they're written in the form ax squared plus bx plus c equals 0, where a is not equal to 0. If a were 0, then we would have bx plus c equals 0, which is called a linear equation. In this video, we go through 4 methods that we use to solve quadratics, which are namely factoring, completing the square, the famous quadratic formula that I'm sure most of you have heard of, and finally, we will sketch a graph to find solutions to a quadratic equation. We start by looking at factoring. Let's say we were given the quadratic equation x squared plus 5x plus 6 equals 0. When factoring, we want to find two numbers, let's say r1 and r2, that will multiply to c, which in our case is 6, and those two numbers also need to add up to b, which in our case is 5. This example is simple, as it's easy to see the two numbers that satisfy both these criteria, which are 3 and 2. This means that we can factor this equation as x plus 3 times x plus 2 equals 0, and we treat each bracket one at a time. When x plus 3 is equal to 0, we have x is equal to minus 3, and when x plus 2 is equal to 0, we have x equals minus 2, and therefore our solutions are minus 3 and minus 2. The problem with factoring, however, is trying out all the different combinations of numbers, and this can get tedious very quick. I mean, imagine solving this equation by factoring. There are so many factors of 30 that it would take a while to get the final answer, and this is where completing the square comes in, which is honestly just factoring, but more clever. The intuition behind it is to consider a generic quadratic equation, and we divide both sides by a. We then notice that if we write it factored in this particular way, as a bracket squared plus something else, we can take the remaining things to the other side, and then we just take the square root and rearrange the equation to have our solutions. Let's use actual numbers to make this easy to understand. You can't even factor this equation right away, and this is where completing the square really shines. We can write this equation as x plus 4 squared minus 16 plus 13 is equal to 0, and then this can be written as x plus 4 squared is equal to 3. We can then take the square root of 3, and we have plus or minus the square root of 3, and we rearrange to find the solutions for x. This leads perfectly into the quadratic formula, which is really just a generalization of completing the square. With some rearranging of this equation that we saw before, we arrive at the famous formula, and this is a foolproof method of always finding the solutions to any quadratic equation. Working with this equation, all we have to do is simply put the numbers into the right place and we will have our solutions for x. However, I will leave you with an interesting question. What happens if b squared minus 4ac is actually less than 0? Do you see why this would be a problem? To understand this, we need to see what quadratic curves actually look like. We will sketch a curve from scratch. This is very simple, as we choose different x coordinates and plot the appropriate y coordinate on the axis, and at the end we connect the points together and form a smooth curve. This is the curve y is equal to x squared plus x minus 2. Now I want you to focus on where this curve intersects the x-axis, which are the points x is equal to negative 2 and x equals 1. This actually means that these are the two solutions to this quadratic equation. Now, there are 3 scenarios that I want to consider. On the screen, you can see 3 different quadratics, and each of them have a different equation. Considering b squared minus 4ac for all of them, you can see that when this is greater than 0, we have the curve intersecting the x-axis at 2 different points. When it is equal to 0, we have the curve intersecting the x-axis only once, and when it is less than 0, the curve never intersects the x-axis. I will leave you to think about this and why this happens.